Hello students. So in the previous class we discussed transpose of a matrix in the last concept, I think. So what is a transpose of a matrix? Transpose of a matrix is what? Interchanging the rows and columns of a matrix. If you interchange, say for example, I will rewrite it, I will remember that one, 2 1 minus 1 0 6 4. This is a matrix. Then the transpose of the matrix is given by A dash is given by what? 2 1 minus 1 0 6 4. This is a transpose of a matrix or A dash or A transpose. You can write like this also. Okay. Now we will discuss some problems related to that. Next we can observe. He may ask the question like this: if A dash is equal to 2 1 6 4 and B is equal to 1 0 5 minus 2. This is the B matrix. Then you may ask the question. Then find A plus 2B whole dash. A plus 2B whole dash. So for that, what I will do, I will find out first, I will find out A plus 2B. Then whole dash later we can do it. A plus 2B. A plus 2B. But you look at this given data, it is A dash. I have to first write A. So what is A? A dash making a transpose again. 2 1 it is here. 2 1 I will write here. 6 4. Why? Because this is A dash. I have to write A plus 2B. You can write it directly. Better 2B. Directly you can write it. No problem. 2 into B. B matrix, entire matrix B is multiplied by 2. Better. 2 into 1 2. 2 into 0 0. 2 into 5 10. 2 into minus 2 4. This is the B matrix multiplied by 2. Okay, if you are not getting, just rewrite it 2 into B matrix. Next step we can take that. Adding the matrices becomes so easy. 2 plus 2 becomes 4, 6 plus 0 6, 1 plus 10 11, 4 minus 4 0. This is the A plus 2B matrix. Then A plus 2B whole dash means what? A plus 2B whole dash is what? 4 6 11 0. Row becomes column, column becomes row. This is the A plus 2B whole dash. Or else he can rewrite it. He can, by using the property A dash plus 2B whole dash. Like this, you can also write it. A dash plus 2B dash. If you calculate this, it will be same. You can do it like this also. Okay. Now we will move for next example. Here they ask the question: if A is equal to cos alpha sin alpha minus sin alpha cos alpha, then verify that A dash into A is equal to R. A dash into A is equal to R. Look at this. A dash into A. The given data is A matrix he has given. Cos alpha sin alpha minus sin alpha cos alpha. A matrix they have given. A dash into A. A dash into A we have to find. Just we can write A dash into A. Verify. Verify means is it possible or not? Let us look. A dash. How to write A dash? Making a row and column interchange. Cos alpha sin alpha becomes row becomes column here. Cos alpha sin alpha. This is a row here. Minus sin alpha cos alpha. This is the A dash into A matrix. A matrix is what? Keep the A matrix as it is. Cos alpha sin alpha minus sin alpha cos alpha. Matrix multiplication easy to calculate now. How to calculate? First column, first to second column. Just cos alpha into cos alpha, it becomes cos square alpha. Move here, move down. Minus sign into minus sign becomes plus sin square alpha. Cos square alpha plus sin square. First row, first column over. Next cos alpha, sin alpha. Keep as it is here. Cos alpha, sin alpha. Next minus into plus minus, sin alpha, cos alpha. First to second column over, next second row, first column. Sin alpha into cos alpha, sin alpha into cos alpha. Move here. Cos alpha into minus sin alpha becomes minus cos alpha, sin alpha. Next sin into sin, sin square alpha. Next cos into cos, cos square alpha. So the entire matrix multiplication. First row, first column, first row, second column. Second row, first column, second row, second column. Okay, now simplify this. We know the identity very important. Cos square theta plus sin square theta is always equal to 1. So cos square alpha plus sin square alpha equal to 1. And what happened? These two gets cancelled, opposite sign. Now this is also, both are same, opposite sign cancel. So 1 0. This is sin square alpha, cos square alpha 1. So this is nothing but what? Identity matrix I. That's why verified. A dash into A is always equal to I. A dash into A is always equal to A. Sorry. Similarly, we can find one more, same little bit change. We can little change. If A equal to sin alpha minus cos alpha, sin alpha. Then same question, verify A dash into A is equal to 1. A dash into A is equal to 1. Check. Same thing. Little change. What is the difference between these two questions? A is a sin cos, there is cos sin, minus cos sin, minus sin cos. Little change. But we will check it. A dash sin alpha, A dash becomes, this row becomes column, minus cos alpha, sin alpha. Into A. A means this is A. Sin alpha, cos alpha, minus cos alpha, sin alpha. Same thing, almost similar, not much difficult thing here. So first row, first column, sin into sin, sin square alpha, minus into minus plus cos square alpha. Sin into cos, sin alpha into cos alpha, minus cos into sin, cos alpha into sin alpha. Next this is cos into sin, cos into sin, plus into minus, minus cos alpha, sin alpha into cos alpha, sin alpha, cos alpha. Next cos into cos, cos square alpha. Next sin into sin, sin square. No difference, almost similarity. We get the same, little bit almost similarity between these two questions. This is 1, this gets cancelled 0, this gets cancelled 0, this is 1. This is nothing but I. Same. Almost similarity is there. Now, this is some standard examples till so far we discussed. Now, we will continue next point, that is a symmetric matrix and skew symmetric matrix. There is standard different types of matrices, and definitely there is a question regarding that for 1 marks or 3 marks related to symmetric and skew symmetric. Let us look for that. So we will discuss one by one. Symmetric matrix. Symmetric matrix. Definition: there might be a chance of asking for 1 mark. So 1 mark they may ask the question. Define symmetric matrix. They may ask this question for 1 mark, and related to that examples also will be there. Let us look for that. I will write it. A square matrix. It should be what? A square matrix. I am mentioning a square matrix. A equal to a square matrix. A is equal to Aij. A square matrix in the sense what? Number of rows is always equal to number of columns. A square matrix A equal to Aij is said to be symmetric matrix. Is said to be symmetric matrix if A dash is equal to A. If A dash is equal to A dash is always equal to A, then We call that matrix as a symmetric matrix. I will write 2 examples. In that, we can observe which is symmetric, which is not symmetric matrix. Just look for example. Let us, I will take A matrix. One matrix is there. It should be a square matrix. Be careful. 2, -3, 6. This is a A matrix. Okay. What about A dash? What about A dash? What about A dash? How I said? How to make a transpose? Row becomes column. 2 -3. -3, 6. Observe, I made row as a column, row as a column. I interchanged rows and columns. Even though A dash, no difference. Both are same. That's why it is called it is called symmetric matrix. Observe the point. If I take one more example, you will get the clear idea. 1, 2, -3, 6. If it is a question, whether it is symmetric or not, we will check it now. A dash, check it now. How to make a rows and column interchanging? 1, 2, -3, 6. Observe. Both are same? No. Both are not same. 1, 2, 1 -3. So A dash is not equal, this is not equal to A. Therefore, this is not symmetric. That is not symmetric. This is a symmetric. These are the order 2 square matrix. I will take one more example. Just observe order 3 matrix I will take. 1, 2, -3, 2, 5, 6, -3, 6, 4. If it is a matrix. Okay? Now come to the point. A dash. A dash. How to make A dash? I said A dash is nothing but interchanging the rows and columns. 1, 2, -3. 1, 2, -3. This is what interchanging the rows and column. 2, 5, 6. -3, 6, 4. Observe the point. What happened? Both are same. Observe. Yes. It is equal to A. Therefore, A is what? A is symmetric matrix. Isn't it? I will take one more example of order 3. Just observe. 1, 2, 4, 6, 0, 5, -1, 3, 5. 1. You get it. A dash is equal to what happened? A dash is equal to 1, 2, 4 like this, 1, 2, 4 like this, isn't it? Next 6, 0, 5, -1, 3, 1. Is it A dash? Yes. Both are same. 1, 6, -1, 1, 2, 4. Therefore, it is not equal to A. This is not a symmetric matrix. That is not a symmetric. This is a symmetric. There is a definition. What it states? A dash is always equal to A. Then such matrices are called symmetric matrices. Now come to the point, how I am choosing. So you are writing the examples in your own way. I want to know how to write the symmetric matrix. I want to know how to write the symmetric matrix. Simple way. Symmetric in the sense what? Symmetric in the sense what? This is symmetric. Exactly. If I take these 2 hands, what happened? Hold it. What happened? This exactly become symmetric. The same concept here also. Just observe. This is a matrix symmetric. Just this is what I said. Diagonal, principal diagonal, or diagonal you can take it square matrix and make it fold. Make it fold. This is a entire diagonal. Make it fold. What happened? 2 same. -3 same. 6 same. Therefore it is symmetric. Observe here. At same point. Observe. 2. What happened? 6. No. If I make it 4, what happened? Both the numbers must be same. Then only it is called symmetry. You can make an example. Now we can write it. It is easy to write. You people. 2 minus 6, 4. What I have to write here? You can predict. What I have to write? -6. You must write -6. Diagonal whatever. Don't worry. Here 3 if I write. So what I have to write here? Just think it. I will write it. Here this element compulsory 4. Here this element 3. This is whatever. Diagonal whatever. Okay. This is the idea related to symmetric matrix. Or I will redefine the symmetric matrix definition. Come to the point. Symmetric matrix definition is what? Symmetric matrix definition is what? A square matrix A is said to be A equal to Aij. What is Aij indicating? Aij indicating what? It is a position of the element. Is said to be symmetric if A dash equal to A. I will write that is Aij. I will write Aij is equal to Aji for all ij. This is same as this. Both are same. Same element. Aij is equal to Aji. Aij equal to Aji means what? Positions. If I write one example, this is the symmetric matrix. One example, one more example I will write it. One more example, 1, minus 2, 3. How do I have to write it? This is minus 2 only. This is whatever, no problem, 6 whatever. 3 must be here, 6 must be here, whatever. Okay? What I find? This is a position. Can you imagine? Can you remember the point I said? What is the position of minus 2? Position is what? First row, second column. First row, second column. First row, second column. Interchange it. What happened? First row, second column becomes second row, first column. Second row, first column, which position? Second row, first column. First row, second row, first column. This is what? A1, 2, isn't it? This is what? A2, 1. Are you remembering that point? This is the position A1, 3. This is the position A3, 1. Both are same. This is the position of A2, 3. First row, second row, third column. This is what? Third row, second column. Whatever, these things. Okay? Generally, I will remember that one. A11, A12, A13, A21, A22, A23, A31, A32, A33. This is a square matrix of order 3. Remember that point. Observe. This must be equal to this much. What happened? 1, 2, 2, 1. I, J, J, I, J, J. 1, 3, 3, 1. 2, 3, 3, 2. Both must be same. This is called symmetric matrix definition. Okay? That will help for competitive exams. And now we will discuss skew symmetric definition. This is the main point for competitive Aij equal to Aj. Simple, very basic point in symmetric matrix. If they ask in exam what is symmetric matrix, what you have to write? What you have to write? A square matrix A is said to be symmetric if A dash equal to A. If A dash equal to A. Now we will make another definition. Skew symmetric matrix. Skew symmetric matrix. Same way we will define it. A square matrix. A square matrix. A equal to Aij. A equal to Aij is said to be skew symmetric if A dash is equal to minus A. If A dash is equal to minus A. If A dash is equal to minus A means, what is the difference between last symmetric? What we did it? A dash equal to A. Here A dash equal to minus A. One example I will take. There is also one rule. I will tell you later. A matrix, if I take 0, minus 3, 3, 0. If it is like this. What is it? A dash. Interchanging the rows and columns. 0, this is the row, this becomes column. This is the row, this becomes column. Right? Taking minus common. Both are same or not? Both are same? No. Both are not same. 0 minus 3, 0, 3. Not same. I will minus take outside or minus multiply. Minus if I multiply 0, minus 3, plus 3, 0. Minus in multiply, you will get this side. So what happened now? It becomes A only. So minus is there, I will keep minus here. A dash becomes what? Minus. This is called skew symmetry. I will get the clear idea. If I take one more example, if I take ordered 3 matrix 0, 1, 2, minus 1, 0, 5, minus 2, minus 5, 0. There is a logic. There is a logic. Find A dash. A dash becomes what? A dash becomes what? 0, 1, 2, 0, 1, 2, minus 1, 0, 5, minus 1, 0, 5, minus 2, minus 5, 0. Both are same? No. Both are not same. 1, 0, 1, 2, 0, minus 1, minus 2. Both are different. Take minus common. What happened? Multiply minus on both all elements. 0, 1, 2, minus 1, 0, 5, minus 2, minus 5, 0. Isn't same? Yes, it is same. Minus outside is there. A dash equal to minus. A dash equal to minus. That's why this is also called skew symmetric matrix. If I take one more example. 3, 4, 1, 2. What happened? A dash is equal to what? 3, 4, 1, 2. 3, 4, 1, 2. Take minus common. What happened? Minus 3, minus 1, minus 4, minus 2. Is it same? No. Both are not equal. Therefore, this is not skew symmetric. I will come to the point that how to write a skew symmetric matrix. Like previous example, I say skew symmetric matrix means here, that is I will write it. How to write? Aij equal to minus Aji for all ij. Aij equal to minus Aji. How I have written? Just observe. Here I have taken an example. This is a minus 3. Write the opposite side. 3. Opposite sign. Make it fold about the principal diagonal. If you fold, what happens? Minus 3 plus 3. If you are not getting the clear idea, come to this point. This is the leave it. 1. Reflect minus 1. Right, opposite sign. 2 minus 2. 5 minus 5. A11, A12. Observe the point. This is the position of A12. This is the position of A21. What is the difference? Minus. This is the position of A13. This is the position of A31. Opposite sign. And what about the diagonal elements? Diagonal elements compulsory 0. Be careful. In a symmetric matrix, not a problem. In skew symmetry, diagonal elements must be 0. What happened? I said Aij equal to minus Aji. Aij equal to minus Aji. That means in these elements are indicating what? I equal to j. I equal to j means A11, A22, A33. So what happened? Here I equal to j. If I substitute, what happened? Ai equal to minus Aii. I equal to j. If you send here Aii plus Aii is equal to 0. 2Aii equal to 0. Aii equal to 0. So where the diagonal elements are there, those elements must be 0, and non-diagonal elements. Skew symmetric means opposite sign elements. If I fold about the principal diagonal. One more example, I will finally conclude the point skew symmetric matrix definition. If you want to write skew symmetric matrix example, what I will do? Diagonal elements 0. Here if I write 1, here if I write minus 2, 1 is there means here minus 1 you write it. Here 0, if I write any element 3 here, if I minus 2, here 2, 3 minus 3, this is 0. Diagonal elements 0 and 1 minus 1 minus 2 opposite sign. You make the use of this trick to write the skew symmetric matrix definition. Okay, we will continue some problems now. Yes, now we will discuss some problems related to symmetric and skew symmetric matrix. He may ask the question like this: show that the matrix A equal to 1 minus 1 3 minus 1, 4, 6, 3, 6, 5 is symmetric matrix. Show that this is a symmetric matrix. How to find? How to show? What is symmetric matrix definition? Symmetric matrix definition is A dash equal to A. We have to find A. It is given that 1 minus 1 3 minus 1 4 6 3 6 5. This is A. Find out A dash. Find out A dash. What happened? A dash becomes what? 1 minus 1 3 minus 1 4 6 3 6 5. 1 minus 1 3. I made it row column interchange. Even though both are same, looks like exactly same. So this is nothing but A dash is equal to A. Conclusion. A dash equal to A. Is it the definition of symmetric? Yes. Therefore A is what? Symmetric matrix. A is what? Symmetric matrix. Okay. Now similarly, if they ask the question, show that A equal to 0, minus 1, 2, 1, 0, 3, minus 2, minus 3, 0 is skew symmetric matrix. Is a skew symmetric matrix. Skew symmetric matrix. So what happened? It is a skew symmetric matrix means what? Observe, we can observe in the just now we mentioned the point. How to think? This is all elements must be 0, skew symmetric, and opposite sign. If I fold, it will be having opposite sign. 2 minus 2, 3 minus 3, minus 1, 0. Yes, minus 1, minus 1. Okay. So how to show means A it is there. 0 minus 1, 2, 1, 0, 3, 2 minus 3, 0. This is the A matrix. I will rewrite A dash. A dash becomes what? Row become column, column become row. 0, minus 1, 2. Row becomes column. 1, 0, 3. 2, minus 3, 0. Is it A? No. 0, minus 1, 2, 0, 1, 2. Both are different. I will take the minus common. If I take common, minus what happen? 0 as it is. Minus 1 becomes minus 1. 2 becomes minus 2. Minus 1 becomes 1. 0. Minus 3 becomes 3. Minus 2. Minus 3. 0. Okay. This is exactly same A. So this is nothing but a minus A. So A dash is equal to what? Minus A. That is nothing but a what? Definition of skew symmetric matrix. Skew symmetric matrix. Therefore, this matrix same 0 minus 1 minus 2. I think somewhere else it is wrong. A, it is A dash minus take common. No, I did wrong, sorry. To given data, I have changing it. So once again, A matrix 0 minus 1 2 1 0 3 minus 2 minus 3 0 0 1 2. This is a making a row column 0 minus 1 2 1 0 3 minus 2 minus 3 0. So this minus if I take common, what happened? This is the wrong I did, sorry. Minus 2. This minus minus plus. So now observe 0 minus 1 2 1 0 3 minus 2 minus 3 0. Yes, it is correct now. So both are same. Therefore it is a skew symmetric matrix. Now come to the point. One of the very important question for 1 marks. Probably you won't get in the textbook. They will ask in examination for 1 marks annual. In a textbook it is not there. Just you can go through the previous question paper, you will get it. Even though I will discuss it now. Just observe. If A is equal to 2 x minus 3 1 5 is symmetric matrix, then find x, find the value of x. It is there question like this, but not exactly this question. I am saying not exactly this question. Probably there is a little change, but concept is same. What is the given condition? It is symmetric. then find the x. What is symmetric definition? A dash must be equal to A, because as A is symmetric. A is symmetric. Okay? What is A dash? Find it. A dash 2 x minus 3 1 5. This is a row becomes column, column becomes 2. A as it is 2 x minus 3 1 5. By equality of matrices, 2 is there, 2 is there. 1 should be equal to what? X minus 3. X minus 3 should be equal to 1. 5 5. Correct? So this implies I can conclude 1 should be equal to x minus 3. Isn't it? Send this here. 1 plus 3 is equal to x. X should be equal to. This is the answer. There might be a question little bit like this in annual examination. Be careful like this question. If you know the definition of symmetric matrix, you will get that clear idea. I will solve one more question of order 3, same similarity. If this is a matrix 3 1 x plus 2, this is x plus 2, 1 5 minus 1 4 minus 1 6 is symmetric, then find x, same question but order 3, this is order 2. What happened? If it is symmetric, A dash should be equal to A. What is A dash? Find out A dash. 3 1 x plus 2. Row becomes column. Next 1 5 minus 1 4 minus 1 6. Row becomes column. A is the same as it is. 3 1 x plus 2 1 5 minus 1 4 minus 1 6. What is the question? We have to find x. Where is x variable? It is there here. Right? X plus 2 should be equal to 4. So that is a 4 should be equal to x plus 2. Isn't it? Now send this here. 4 minus 2 is equal to x. X is equal to what? 2. This is a, like you can do like this, or else I said for 1 mark no problem, you can do it directly. So what happened? Leave this. 1 should be equal to 1, correct? And x plus 2 should be equal to, directly I can say 4. X plus 2 should be equal to 4. X is equal to 2. Directly you can write it. No problem. For 1 mark also you can observe. Similarly, I will solve the related to skew symmetric question. If A is equal to 0, x minus 2, 0, 1, minus 3, minus 1, 0, y minus 4, 3, minus 1, 0 is skew symmetric. Find y. How to find y? Skew symmetric. You can make use of a dash equal to minus a. I will do it another way. Observe 0 0 0 0. Correct? Skew symmetric. 1 is there, minus 1. Correct? And minus 3 is there, plus 3 is there. Correct? Then y minus 4 must be equal to. Most of the student will write is equal to minus 1. No, it is not correct. Why? Because 1 and minus 1 are correct. Opposite sign. Minus 3 plus 3 correct. Opposite sign. But y minus 4 equal to opposite sign of minus 1 is what? Plus 1. Got the idea? So y should be equal to 5. This is a question. Probably you won't get like this question in textbook. But they will ask the questions related to symmetric matrix and skew symmetric matrix like this. Or else, if sir, I am getting very confused in this skew symmetric matrix. But symmetric I am getting. In skew symmetric, if you are not getting the idea, what is a skew symmetric definition? A dash equal to minus A. And be careful, some of the people will use A dash equal to minus A. Instead of that, some people will do like this, minus multiply, simple way, don't make it confused. If I take minus out here, minus multiply, what happens? Minus A dash becomes A. There might be a definition, it will change, don't make it confused. A dash equal to minus A, definition. A dash is what? 0, row becomes column, 1, minus 3, minus 1, 0, y minus 4, 3, minus 1, 0. This is A dash is equal to minus A. Minus A becomes what? Minus of A. A keep as 0, 1, minus 3, minus 1, 0, y minus 4, 3, minus 1, 0. So here what happens? 0, minus 1, 3, keep as it is. 1, 0, minus 1, minus 3, y minus 4, 0, keep as it is. Making minus multiply here. 0, minus 1, minus plus, minus plus. Minus plus, 0. Minus multiply here. What happened? Y minus 4 becomes minus y plus 4. This is minus 3, minus plus 1. This is 0. Now you can make use of these things. Where is variable y? Y minus 4 should be equal to 1. Y minus 4 should be equal to 1. Y should be equal to 5. Again we got the same answer. If you are getting confused, but the direct is better. Y minus 4 should be equal to what? Plus 1. Opposites. Okay? If it is 1, what happened? If it is 1, y minus 4 should be equal to minus 1. Like this. Simple. Okay? We will do some more examples regarding skew symmetric matrix. Observe the point. I will make it generalized later. If A equal to 1, 2, minus 3, 6, then show that A plus A dash is symmetric matrix and A minus A dash is skew symmetric matrix. A plus A dash is symmetric matrix, A minus A dash is skew symmetric matrix. We have to show what is the given question. It is order 2, square matrix of order 2. A plus A dash we find out, we have to show that is a skew symmetric. Okay? Now find A plus A dash. A plus A dash. A is what? 1, 2, minus 3, 6. Plus A dash is what? 1, 2, minus 3, 6. Isn't it? So add those. 1 plus 1, 2. 2 minus 3 minus 1. 3 plus minus 3 plus 2. Be careful. Minus 1. 6 plus 6, so 12. Is it symmetric? I said in the last just few problems back only, I said symmetric is what? Isn't it? These diagonal elements, opposites, these diagonal elements except diagonal elements same. Or else let us take this is a P. P dash. Just I will take this is a P. Which one? A plus A dash I will take. P. P dash becomes what? 2. Row becomes row becomes column. Column becomes row. Both are same. P dash equal to P. P dash equal to P. Therefore what happened? P is symmetric. P means what? A plus A dash is symmetric. Therefore P is nothing but what? A plus A dash is symmetric. What about next question? A minus A dash. A minus A dash is a skew symmetric. Let us look for that. A minus A dash. A is what? 1, 2, 3, minus 3, 6. Minus A dash is what? Make it A dash. 1, 2, minus 3, 6. Making row and column and interchange. What happened? 1 minus 1, 0. 2 minus plus 3 becomes 5. Minus 3 minus 2, minus 5. 3, 6 plus 6, 6 minus 6, 0. Okay? Is it identify? Can you identify directly? Diagonal elements 0, non-diagonal element opposite sign 5 minus 5. Is it right? Or you can verify. let us take this is a Q. I will take Q dash becomes what? 0, 5, minus 5, 0. Row becomes column, column becomes row. Taking minus outside. 0, 5, minus 5, 0. Both are same. This is nothing but a minus outside this there, Q. Q dash is equal to what? Q dash is equal to minus Q. What is therefore Q is what? Skew symmetric. Skew symmetric Q. Q is what? A minus A dash. A minus A dash is what? Skew symmetric matrix. That's why, observe the point I said, I will make it generalized. I said, for any square matrix, if you take any square matrix, not this order 2, order 3, you write any number, you write a square matrix of order 3, square matrix of order 4, A plus A dash is always equal to, is a symmetric, A minus A dash is always a skew symmetric. Okay, that proof I will discuss in the next class. In next class, I will explain, I will give the proof of generalized A plus A dash is always symmetric, A minus A dash is always a skew symmetric, and one of the important 3 marks question we will discuss in the next class. I hope you got the idea. Thank you.